Hi everyone, this is the lecture for Math 222 for March 20th. And today we're going to look at the SQL syntax for inner, left, and right joins. I know we did look at how to do joins earlier, but it's what I described as a poor man's join. So today we're going to look at more expanded syntax. And also we're going to look at the syntax for compound primary keys. In the previous lectures, we did have primary keys, but really the syntax I gave you there only allowed for one column to be declared as the primary key. So today what we're going to do is we're going to expand that, and we're going to allow for multiple columns to uh, allow for to be part of the primary key. So let's begin first by logging into our Moodle site at freeskies.net, and it's the usual username password. And so we'll log in there and scroll all the way to our class, which is Math222, and scroll all the way to the bottom. And here's the notes for today's lecture, basically on joins and compound keys. And so we'll begin by clicking there. Now, I'll review the old syntax in just a second. Let me just show you the new syntax. So MySQL allows you to do inner joins, which you can do by the old syntax, but it also allows you to do left and right joins, which you really can't do using the old syntax. And the reason being is that in the where clause where you have the equal sign is a match. And nulls, which are allowed in left and right joins, they never match anything. And so there's really no way to expand the syntax that I gave you earlier to allow for left and right joins. There doesn't seem to be anything that does full joins in SQL, at least my SQL, and cross joins where every single row in one table is just paired with every single row in another table are absolutely trivial, and so there's no reason to have any kind of special syntax for that. Okay, so let's start off by looking at this expanded syntax, and so let's take a look at this right here, that syntax right there. It might be a little bit hard to see. Let me see if I can expand this. See, is that a little bit better to see? Yeah, let me maybe make it a bit bigger. Okay, now we can definitely see it. Okay, so it does make use of the select command, and so you start off with select, and then you list your column list in the same way that you did for the previous examples that I did with select. Asterisks will select every single column. Otherwise, you can list the columns that you want, or you can do concatenations on columns and the like. And then and then you state the first table, and this would be the table on the left of the join. Okay, and so unlike the previous command where you list all the tables that you're going to be that are going to be involved in the select, here you just list the in the from clause, you just list the table on the left, and then you say inner join, and then the table on the right. Okay, and this makes an inner join between table 1 and table 2, and then you have to say what the join criterion is, and that's the on clause. So this is a new clause. Okay, and so the syntax is summarizing as select column list from table 1, inner join table 2 on the join criterion, followed by a semicolon. Okay, and here I have the words inner join there because that's the most common join, but you can replace inner join with left join or right join, and you would get the corresponding joins. Okay, now that's one of the syntaxes you could use. Another one of the syntaxes, which in some ways is more interesting and more useful, is it's the same select column list from table 1, inner join table 2, but this time you say using and you give it a column list. Now the column lists are supposed to be columns which are common between the two tables that you're joining. And so in the example that I'm going to do in a minute, I have, for instance, a common column name called address ID. And if address ID is in table 1 and the exact same name is in table 2, address ID, then you would put that in the using clause. You would say using open round bracket address ID close round bracket, semicolon, and then it would simply use that column, which is common to both tables, as the join criterion. This is a very useful syntax because this is the one that's going to expand and allow you to have compound keys, that is keys which have multiple columns. So there you can see that I actually wrote common column name, and it could actually be common column names. So it could be more than one. All right. So that's a summary of what the new syntaxes look like. Let's compare this to the old syntax. And so let's say we're looking at that common underscore invoice database that we've been working with. And I'll remind you of the schema in just a second. And we ask, what is everyone's address? Actually, I probably should have said there, what is every customer's address? Okay, so let's take a look at that schema for that particular database. And oh, I think this one I'm going to have to make smaller. All right. And so this was the database where we had customers, addresses, products, manufacturers, and purchases. But we're just going to take a look at two of the tables. We're going to take a look at the customer table and the address table. Okay, so these two tables. These two tables are related to one another in a one-to-many relationship. So a customer has one address, and because not null is allowed there, or is declared there, every customer has one and exactly one address, and but the addresses could be shared between many customers. Okay, so it's a one-to-many relationship, and the shared column is address ID. You could see it there, called address ID, and you could see it there, also address ID, spelt in exactly the same way. Okay, and so in our poor man's way of doing a join that I showed you last class, I have select, and then I'm just going to list off a bunch of columns that I want. I'm going to say list the first name, last name, building number, street number, city, and state from the two tables that are being joined together. That is from the customer and the address table with a comma delimiting customer and address. And then we make use of the where clause to narrow down the join so that it's actually an inner join and not just a cross join. If you drop the where clause, you get all of the tables, every row matched with every other row. Okay, so here this is going to make sure that we have a match between the ID, address ID in the customer table with the address ID in the address table. Okay, so basically it's a primary key in the address table and it's a secondary key in the customer table, and this works perfectly fine. But in the new syntax, the way this would work is you would say select, and then again you would list off all of the columns that you want. I just noticed that I think that's misspelt. It should be first name, but it should be spelt as that. Okay, I'll fix that later. I apologize, guys. It should be first name. Only the N is capital, not the entire name there. Okay, so that's first capital N name, but not all NAME all uppercase. Okay, minor point, but I just wanted to point it out there. Okay, so here using the new syntax, it's select column names. Okay, from the table on the left, which is the customer table, inner join with the table on the right, which is the address table, and on. And what's the join criterion? Well, it's like what we had there with the where clause, but now it's placed into the on clause, and it's on the condition that customer dot address ID is equal to address dot address ID. Okay, so when those two are equal, then the record is displayed. All right, that's using the on, but it isn't as good as this particular syntax here. We have select, again, column ID with my typo there. Okay, from customer, the left table, inner join address on the right table, using, and since the address ID is common to both of them, you could just state it there, and that's the column that you're going to use to do the join. So this syntax, the on syntax, or even the other way using the where syntax, there you can have any criteria you like. Okay, so you don't have to call it address ID in one table and address ID in the other table. That's not good because it's hard for the human mind to get your head around a primary key and secondary key that don't have the same name. It's always a good idea to name your primary and secondary keys the same name, which you can do because it's a primary key in one table and a secondary key in a different table. Okay, but if you name them the same in both, then you can just use this using, and that's a very nice little uh, syntax to use there. Okay, and again, I have here inner join and inner join, but you could just as well replace this with left join and right join. Okay, I'm going to demonstrate that in a minute because we're going to log into our server and we're going to do this. I should just point out one thing, and that is in the customer table here, okay, and the schema, I said not null, and not null means that every customer has to have one and exactly one address. Okay, but that's kind of unfortunate because that doesn't allow me to really show an inner join and a left and a right join. Okay, so we're going to change that in a minute. Okay, but let's log in to our server, and we're going to run those commands there. Okay, so to log into our server, let me switch over to the shell. And here we go. I've got a shell, and to log into our servers, it's SSH minus port 2222 and your last name at www.freeskies.net, like that. Okay, and enter in your password, and ta-da, we are connected. Okay, let's use tmux to so we can have several shells going on at once. And just in case I need it, I don't know if I will, but then let's say MySQL minus u username minus p to prompt us for the password. And there we go, we're in. Okay, so show databases like this. And there they are. We have the common invoice database. Let's use that one. Like that. All right. And let's show tables just to see what tables are there. All right. So we're only interested in the address table and the customer table. So let's describe the address table. And there you can see the address table described. And let's describe the customer table. And there's your customer table. Okay. And you'll notice the address ID there. It's an int, as you expect. So this is the secondary key imported from the address table. But you'll notice under null it says no, and we're going to change that, okay, so that we can do the left joins, and or actually exemplify left joins. So what I'm going to do is I'm just going to alter that table. Okay. And here we go. Alter table customer, change address ID to just address ID int. Okay. Now what that does is say, well, it's already an int. I know, but it removes the not null. Okay. And so that's been changed. And now if we take a look at the customer table, you can see that address ID, does it allow null? Yes, it does. Okay. And the other thing we're going to do is we're going to update the, well, let me show you the customers that are in there. So select everything. Oh, let me use capitals. Select everything from customer, like that. Okay. And so there are all our customers. I'm sorry for the wrap. Let me make that maybe a little bit smaller. Is that visible? Well, I'll make it bigger in a second. But you can see there that number 5 is Liz. Okay. So what I'm going to do is I'm going to basically change that. And I'm going to update the customer table. I'm going to set the address ID for customer number 5 to null. Okay, and so you should see here currently Liz Tudor's address ID is number 3, but not anymore. If we take a look now Liz Tudor has no address ID. Effectively, I've made Liz Tudor homeless because she doesn't have an address associated with her anymore. Okay, so now we're ready, and what we can do now is we can just do our select, and here's an example of a select using the new syntax. Okay, and I'm sorry, this is going to fail because first name is incorrectly spelled. Oh, apparently it did work. Okay, it did work, even though it's mismatched. It apparently is case insensitive there. Okay, so you could actually see that it did work. And so what I'm asking for is this particular query says, well, give me the first name, last name, building number, street, city, and state. Okay, and so you got those there. From an inner join between the customer table and the address table, using the address ID to join them. Okay, and what I wanted to do right now is to show you that you can actually, even on top of that, add a little where clause. And so there you could say where the street address is not Porter. So basically I've said what this says is, look, do an inner join for me between customer and address, and it does. When you do that inner join, use the address ID as the common key. Okay, primary key in one, secondary key in the other, and it did. Okay, and I probably should have done the unconditional one first, but then on top of that, you could still have a where clause, and the where clause could say, you know what, I just want everyone who doesn't happen to live on Porter Avenue, and apparently that just turns out to be Mary Fleury. So this is the syntax that I gave you earlier, but expanded a little bit more. Let me show you what you would have gotten if you had done the unconditional, that is without the where clause. And so we're still going to do the inner join like that. And here it is. This is the complete inner join between the customer and address table. Okay, so you can see everyone's name there, and now you can actually see the effect of the where clause. All right, so after you do the inner join using the using syntax, okay, this syntax right here. All right. After we do that join, I can on top of that say, well, you know what? I also want to add some more Boolean criteria to limit the search more. And so I said, look, just give me those where the street address is not equal to Porter. And you can see that Fred Ned does live on Porter, so that he would be excluded. Jim is also excluded. Jill is also excluded. And the only one that isn't excluded is Mary. Okay. So you could see there that we're making use of this new type of syntax, and you can get the you get the joins. Okay, now I did the inner join there. Let me show you the left and the right joins. Okay, so you remember with the left join, every single customer will appear whether or not they have an address. Okay, so you can take a look at the unconditional join there without the where clause, and you can see that you're getting 4 people, but there's actually a 5th person in the customer database. In fact, if we take a look, select everyone from customer, you can see that, yeah, there's Fred, and there's Jim, and there's Mary, and there's Jill, but there's also Liz. Now, Liz wasn't included in the inner join because Liz did not match an address with the null, okay? But if you do a left join, the left join insists that every single row in the customer table must show up, and so we should get the same result with a left join, but with Liz, and then all nulls for the building number, the street, the city, and the state, and so on. Okay, so let's go ahead and do the state, the select there. And I apologize for that, the typo there, but apparently it's this dialect of SQL MySQL doesn't seem to care about the upper lower case. It does the match anyhow. So we're going to do this from the customer table, and now we're not going to do an inner join. We're going to do a left join. So left join address. Okay, and using the address ID like that, and ta-da! Now what you have is actually all 5 records from the customer table, all 5 rows from the customer table appearing, okay, including Liz Tudor. All right, but with Liz, because Liz doesn't have a building number, doesn't have an address, doesn't have a building number, a street number, a city, or a state, you get all nulls for her address, okay? And so the null that was, you can think of it this way, the null that was associated with the address ID is, just equals to some null record, which is in the address table. Okay, that's one way to think about this. All right, so there's not that much more to say about this. I didn't use the other syntax. Let me do that now just to show you that it certainly works. Instead, that one works with on instead of using. So let's do the exact same thing. All right, so we're going to select all the columns we want from the customer table, and what the heck, let's do the left join again. But now, rather than saying using in the column that we're going to use, we're going to just do on. And on is very much like a where clause, okay? And you can have an on clause and a where clause, but the on clause is really for the join, whereas the where clause are further criteria that you might want to use on after you've done the join to narrow your search. Okay, so they are different. Okay, you shouldn't mix the two because the on is really going to affect the join criteria, and that will make a difference when it comes to things like the left join, because of this business that nulls don't match anything. So in the where clause, nulls basically don't exist, whereas in the on clause for left join, they kind of implicitly do exist. Okay, so anyhow, how do we do this now? So this is more like the where clause in the earlier example of the joins. So we have to say, okay, out of the customer table, we want the address ID, like that. And we want to make sure that that's equal to the, in the address table, the address ID there, like that. And ta-da, you get the exact same answer. Okay, I think you would agree with me that the using syntax is much nicer, but it does imply that when you implemented the schema, that you made sure that all your primary and secondary keys were named exactly the same uh, name. Okay, which we would do anyhow, because also for human, it's also for human consumption. Okay, so that's it for the section on expanded syntax of joins. Let's take a look next at compound keys. Okay, so there's an alternative syntax to how we do compound keys. All right, and so I think here we go. Can you see it now? Yeah. So an alternative syntax to declaring primary keys. Okay, the old syntax was to use this syntax right here. So basically what it does is it says, let me make that just a bit bigger again. Yeah, all right. Okay, so it says create table student, and this is out of a different database. Okay, so think of it as starting out with a fresh example. It's not part of the common invoice database that we've been working with. So we have create table student, and then we have a student ID there, which is of type int, and it's going to be declared as the primary key, and it's auto increment. And then we have a first name, which is varchar not null, and the last name varchar not null. Okay, and this is perfectly fine. All right. However, this way of declaring the primary key is only going to work for one column. And so in this case, the student ID column is basically your primary key. But how would it work if you had several columns that you wanted as your primary key? You really can't put primary key on several of them, and so it doesn't work that way. All right. So here's an alternative syntax. All right. Here it is. Okay, and remember, it's still, this alternative syntax works even for just one column. Okay, but the previous syntax doesn't expand to multiple columns, whereas this syntax does. Okay, so here we have create table student, open round bracket, student ID int auto increment. You go, where did the primary key go? Well, it's not there. It's at the bottom of the table. Okay, and then you got the first name declared the same, last name declared the same, and notice at the very bottom you've got primary key. Okay, and open round bracket, student ID, close round bracket, and that basically declares that for this table, the student ID column, which is the first column in the table that you declared in the table, that student ID column is going to be your primary key. Okay, the int and the auto increment, they're perfectly fine. You can just leave them where they were. Okay, all we really did is just take the primary key out of the declaration up here, and we moved it to the last line in the table like that. Okay. Um, so how does this expand if you want to have a compound key? That is a key that's made up of several columns. Now you remember when we did the normalization, okay, the primary key had to uniquely identify a row, and so you were in situations like suppose you said, well, I'm going to use, instead of using some artificial integer that I'm going to add to this table, like a student ID, I want to use the first name and the last name. You can't use the first name by itself because you're going to have multiple Johns, you're going to have multiple Marys, and so on. And so the first name by itself is not going to be a unique identifier for a row. The last name itself might not be a unique identifier for a row because you might have John Smith, okay? And even the two together, the first and last name, might not be enough, and so maybe you'd have to add a birthday. But for the purposes of this example, let's assume that the first and last name are sufficient to uniquely identify a row. Okay, and so it's a determinant for an entire row. Okay, so how do you do that? Well, take a look here. You've got the first name, which is declared varchar and not null. Okay, and you've got the last name, which is declared varchar and not null. And then you say, okay, primary key. And what's the primary key? It is now a compound key. Okay, and so you have a tuple here, and the tuple is made up of your first name, comma, as the delimiter, last name. Okay, and that's for 2. Of course, if you had 3, you would just list off all 3 columns, 4 columns, and so on, and then enclose them with round brackets as a tuple. Okay, so if we run this and then run describe on a student, you'll actually see this, and you'll see that the column that says primary key will show up twice. I think now is a good time to actually do this on our shell. So let me switch to the shell here. All right, and let's take a look here. Show databases like that. Okay, and I've got common students. I'm going to drop that because I think that's the one I was using before. Drop database. Sorry, that should probably be all in capitals, but it's not going to be sensitive to it. Let's just drop it like that. Okay, so we drop that. So now let's do create database common underscore student. Okay, let's use that database. All right, and show tables. Well, you know there are no tables. Okay, ta-da. So if I were to create the first table, so this is the table using the old syntax. All right, and then I say describe student. You'll see that there's a description of all the 3 columns, and you'll notice here that the primary key is only a designated for the first column there, student ID. Okay, so all right, let's drop that table. So drop table student like that, and let's recreate it using the new syntax. And whoops, something went wrong. Oh, I see. There's actually a syntax error in my notes. I apologize. I will fix that. It is well. Let me actually paste it in. See right here? What did I do? I have a semicolon right there at the end, so I want to get rid of that semicolon. Okay. All right. And did that work? Yep, it did. Okay, so there's a little bit of noise in there. I apologize. You know what? Let me just do that one more time, just so you could see it done properly. Okay, and I'll fix that syntax error later in my notes. There you go. There it is, properly typed out. What I had was for reasons that I don't know, I had a semicolon right at the end here, right after that round bracket that I've got highlighted. I put a semicolon there, and there should not be a semicolon there. Okay, so let's now hit enter and describe that table. So describe the student table like that. And whoa. Oh, yeah, that is correct. I apologize. There you could see that this alternative syntax, we said that the primary key was the student ID, and it's still the primary key. Okay, let's drop this one more time. Where's my drop command? All right, and this time let's do the compound key. So here it is. Okay. So in the previous example, I just showed you that the new syntax was just as good as the old syntax to designate one column as your primary key. But the new syntax will generalize and allow you to pick 2 columns as being part of your compound primary key. And there we go. And now if we describe the student table, you could see that both of those columns form part of the primary key. Okay. So now what? Well, we can go ahead and we can insert into that table. So we're just going to insert into student the values Fred Flintstone. And if we hit enter, of course, that worked just fine. Okay. I don't want to do the select. I mean, I'll do that in a second. But for sure, there's going to be one record in there that is Fred Flintstone. If I try to do it a second time, I shouldn't be able to do that. Why? Why should I not be able to insert that a second time? Well, because the primary key has to be unique, okay? And so you can't have this primary key repeated twice. And so if I hit enter, it gives an error and it says duplicate entry Fred Flintstone for primary key, okay? Now the first name by itself can be duplicated, and so it's certainly perfectly fine to say Fred Rubble, like that. That will work. Or it's also fine to have Flintstone as the last name. That can be repeated, and we can have a different first name, Wilma. Okay, but you can't have Fred and Flintstone repeated. Okay, so the first name by itself is not a primary key. The last name by itself by a primary key, but the two together must be unique. Okay, and now we can do the select all records from the student table. And there you go. So you had Fred Flintstone, and I tried to insert that twice, and it says no. Can you have a repeated first name? Sure you can. There's Fred twice. Can you have a repeated last name? Sure you can. There's Flintstone twice, but you cannot have a repeated first and last name. Okay, so you could see that it is acting as expected as a primary key, but a compound primary key between um, two columns. All right. Now, how do we do joins with this? All right. So let me switch back to our Moodle site, and the new syntax for the joins and the new syntax for the compound keys, they go together because that using clause that I described earlier allows you to do compound keys, to use compound keys for matching between tables when you do joins. Okay, so what I actually have here is, and I could have made them separate files, but they're short enough that we'll just cut and paste them. I have a full example of creating a new database. Okay, so here we go. We create a new database, populating with two tables, and then inserting some data, and then doing some joins on that data. But the joins are going to be making use of the new syntax, and in particular, the new syntax on using a compound key. Okay, so the first thing, let's just cut and paste these 3 lines because these are very typical lines. Okay, and so I'm going to switch back to the shell here. So these are very typical lines. The first line here, drop database if exists. Okay, the database did exist and we dropped it, and then we created a new. Now, why do you do this? This is a way of totally wiping out a database that's there. And you don't want to do this if if it's a database that's in use for obvious reasons, because you not only lose the schema, but you lose the data that the schema is holding. And so this is only something that you do when you're just playing with the schema, as we are now. So we drop the database first, and then we created a new, and it's fresh, and then we use it. It becomes our default database. Great. This is the database level commands. Then we're going to create 2 tables. The first table we're going to create here is our student table. This is identical to the the last table that we just looked at. So it's a create student table. There's a first name, there's a last name, and the primary key is both of them together. Okay, and so great, that's created. In addition to that, we're going to create another table, and this table is a phone number table. Okay, so here's our phone number table. And the phone number is going to use the first and last name as a secondary key from the other table. Okay, so remember now, if you have a secondary key in another table and it's a compound key, both pieces have to be there. So the first and last name, they're in the phone number table because they together form the secondary key that corresponds to the primary key in the student table. In addition to that, the phone number has to have, there has to be a phone number, and that phone number itself is going to be the primary key. Probably not the best way to do this, but it's good enough for our purposes. This is just a little play example to work with. Okay, and great, now it's created the tables. And just to see that they are, they have the schema that we want, let's describe the student table, and it should be identical to what we had before. And let's describe the phone number table, and you could see here that the first and last name, they are not primary keys, so there's nothing in there because they're secondary keys. Okay, only the phone number itself is the primary key for the for the phone number table. So this is more like when we were doing the normalization and we were actually making use of columns, attributes of the entities that we were talking about. We were making use of those as our primary keys, either compound or individual columns. Okay, and so it's very typical, and it's a little bit lazy sometimes to simply slap a new ID on a table, just a student ID or phone number ID. That's not always the best idea. Okay, and with experience, you start to realize when you want to do that and when you don't. Okay, and so if your SQL doesn't allow for this expanded syntax, then it would be extremely limited. Okay, you have to allow for the possibility of compound keys, and so here we are. All right, great. Now we've got the scheme in there. The next set of SQL instructions are just going to be to insert some data. And so here we go. I'm just going to insert Fred, Wilma, Barney, and Betty Rubble. Okay. Now, I don't know why I did it in 4 separate commands. I could have just as well have done insert here. Let's do this. I could have done that, comma, and then that. Okay, so let me just do those 2. All right, and then I could have done all of them like that, but I chose to do 1 on each line. Not going to do that now, but I'm not going to take it out and show it now. But I can hit enter here, because what's going to happen is you're going to get errors. You're going to get errors because Fred Flintstone was repeated, and so was Wilma Flintstones. Okay, and as a primary key, you can't have them repeated. So select everything from the student table just to take a look, and there they are. There's our 4 Hanna-Barbera characters from the 50s and 60s. Okay, so we've populated the student table. How about populating the phone number table? And you know what? For this one, I'm going to show you the other syntax. Okay, so this comma, whoops, comma right there, and then I could do Fred again, and then I can do Wilma. There we go. And one more. Betty. Okay. So, and then a semicolon at the end. So this is that other syntax where we just go ahead and insert phone numbers, values. And since I didn't specify the list of columns, it assumes every single column must be listed in the order that they are part of the table. So it was the first name, last name, and phone number. And so it looks like Fred has 1 phone number. Fred also has another phone number. This is the tuple. This tuple here is your first row. The comma delimits it from the next tuple, which is your next row, and then a comma to delimit it from the next row, and then the next row, and then the last row. There it is. And then finally, to end the SQL command, semicolon, hit enter, and that you can see there it actually says records 4. And so these records were inserted, and so we can take a look at them. Select everything from the phone number table, and there you go. There are the 4 records that I just inserted. Okay, now you could see obviously that Fred has 2 phone numbers, Wilma has 1 phone number, Barney has a phone number, and it looks like Betty does not have a phone number. And so when we go to do this left join or right join, you'll see that it'll be different than the inner join, because there's at least 1 person in the student table that does not have a corresponding phone number. Okay, so let's do the inner join first. Okay. And so here we go. So this is going to say, all right, let's do a join. And I want to know the first name, the last name, and the phone number from the student table, inner joined with the phone number table. And when you do that inner join, use the first and last name as the primary keys, the primary and secondary keys. Okay. And so there you go. Now, this isn't the best example because this is identical to the phone number table itself, okay? But nonetheless, it did do it, all right? And you're going to see that there's going to be a difference now when I do a left join, okay? So if I do the same and I do the left join, just to remind you, guarantees that every record in the student table will appear at least once in the resulting joined table. And so you could see that in the inner join we had only 4 records, but with the left join we have 5 records. Why? Because Betty Rubble doesn't have a phone number. Okay, so there you go. You can see the left join. Now the right join won't be any different than the inner join, but just to show you that that syntax is allowed as well, let's do that. Okay, just as an academic exercise. All right, and let's do right join phone number, and then using, and ta-da, it's no different than the inner join, because with the right join it insists that every row in the phone number table must appear at least once, but every number in the phone number table would appear at least once, even with the inner join, because there's always a corresponding record with the table on the right, that is the student table. Okay, so the right join isn't any different than the inner join, but you could see that for sure the left join is different than the right join. And you can see this very nice syntax where it says using, and you simply list all the columns that are to be matched between the two tables. Okay, and so I have the full primary secondary key columns in there, first and last name. Okay, and again there is that syntax error, but apparently it doesn't seem to mind. Okay, so well, there it is. And so let's just review very quickly what we went over today, and then I'm going to show you one more topic, and that'll be the end of this lecture. Okay, so let's go back to the joins. In addition to the just poor man's join, which was, here's an example of it, where all you do is you just basically say select from, select column names from tables that are part of the join where, and then use the where clause to match primary secondary keys. The new syntax allows you to list the columns as well in the select, and then from the left table in the join, and then whether you're inner joining, left joining, or right joining, the right table in the join, and then on with the criteria. Okay, and the criteria, the way the syntax for the join criteria is identical to the syntax that you would have in a where. It's basically a Boolean clause. Okay, but that is not as interesting as this other syntax, which makes use of the using. And here again, select column list from left table, inner join right table, using, and then list off all the columns that form part of the primary key in the one table and matching secondary key in the other table. Okay, so I apologize, my dog is barking. So that's the syntax for the joins. And the syntax for the compound keys is this. Okay, so this is the new syntax for the primary keys. Unlike the syntax where you can the previous syntax where you could just label one column as being a primary key, here you can have several columns as being part of your primary key. And so in our student table, we have the first name and last name as being the two columns that make part of our compound primary key. And the way you use that compound primary key is in conjunction with our new syntax, and you can see it here where I simply say select, and then I list off all the column names from the left table, left join or inner join or right join, but in this case left join with the right table, using, and then list off all the columns that are part of your compound primary key. Okay, so that's all the new material for the joins and the compound keys. Let me just show you one other thing that you might want to do with MySQL, and it'll kind of end the topics that we're going to cover in this course. Come Monday, I'm probably just going to do an example, taking some examples of the tables that we normalized in the first part of the course and showing you how you can use this new syntax to create a more robust, a more lifelike, or more practical and usable database. Okay, so what is this other thing that I want to show you? Well, let me actually, I guess I didn't need the tmux. Let me get out of the tmux here. Okay, and let let me just show you what's I did an ls here. Let me just show you that in my home directory here on the server, you can see that I have all these .sql files like that. And these .sql files, they were the files that we used to put the database into the put the schema and then the data and so on onto the database server. Okay, and so let me just remind you of what's inside this invoice schema like that. And you could see that, whoa, that scrolled a bit too far, but let me just scroll up here. So basically, we're looking at the contents of invoice schema, and you could see here I just have a series of SQL commands: drop database if it exists, common invoice, use it again, and then I create the tables and so on. And then I had the invoice data, and let's see what's inside of that. This is all the data, and there's some wrapping going on here, but that's okay. Basically, use common invoice, and then I just went ahead and inserted all the data that we worked with in that database and so on. And the way we use those, this is the important part, okay? So that was just to remind you what was in those files. The important part was that once we wrote the schema, we could then insert it into the database by using the following command: my SQL minus u. Okay, can you see that? Make that just a bit bigger. Whoops. Okay. Yeah, that's a little bit better. Okay, so my SQL minus user, Basile, minus p, prompt me for my password. And then this little caret here, the less than sign, basically says feed the MySQL database with invoice schema like that, SQL. Now what this did is, if you look inside of the invoice schema, it drops the database and recreates the schema, prompts me for the password, and give it a second, and ta-da, the database that was there in the database server was dropped. It was recreated from fresh. And then I could say, okay, you know what, now I want to put some data into it. And so this was the file that had the data. And so once again, enter the password, and it feeds all of that data into the database. And now that data is in the database. Now, if we were working interactively, you would see that data and you can work with it. But there's another question or another issue that comes up. The data is in the database. Suppose you want to get it out of the database and put it into an ASCII file so that you could transport it elsewhere, or so I could grade it. If I only wanted to look at the ASCII file, I can look at your database in the database server. But, I might want to do that. I might want to actually say to you, just hand in the ASCII file of the database. Or, you might want to do this for backup. This is a very typical backup technique. And the command here is actually called MySQL dump. Okay, and it's exactly what you think it's going to do. It's going to actually dump the database. Okay, so now we go minus u Basile and minus p. Okay, that minus p just says prompt me for my password, because it can try to get the password from other places, and we're not set up to do that. Okay, but now remember, this is a database server. So that means that there's more than one database running there. And it says, well, okay, you want me to dump a database, but which database do you want me to dump? I don't know. So you have to tell it the database that you want it to dump. And so we're going to dump common underscore invoice like this. Okay. And I, at this point, can hit enter. Don't think of that common underscore invoice as going with the minus p. It doesn't. It's its own separate entity. It's part of the MySQL dump command. And so MySQL dump says, well, take a database that's in the database server and pull it out and give it to me in ASCII format. This says do it under permissions of username Basile. This says prompt me for a password. Don't try to search for the password elsewhere. And this says that's the database that I want. Okay. Now if I hit enter, it's going to prompt me for the password as I asked it to, and I'm going to type my password, and a bunch of stuff scrolled by. Okay, so what scrolled by was the entire database. And you go, well, that's kind of awful. How am I going to get that into a file? And the answer is you use this symbol right there. So the other one, I'll show it, I'll remind you of the syntax in a minute, was the less than symbol. This one's a greater than. So this one basically says, look, take all the output that's going to come out of this MySQL and feed it into a file. Okay, and I'm going to call this file invoice dash backup .sql, like that. Okay, and so that's going to create a new file called invoice backup, and I'm going to hit enter here. Okay, it prompts me for the password, and now the stuff didn't splash all onto the screen. Where did it go? It went into a new file, and where is it? There it is. Okay, all right, so let's take a look at that file. We can use Nano to take a look at it. Hopefully there won't be too much wrap. I'm afraid there might be, but let's go ahead. So Nano allows you to edit a file. You know this because you've been using the Nano editor. So Nano invoice dash backup. Let's take a look at what's in there. And Nano does some pretty painting for you. And so there it is. Okay. Now there's a lot of stuff in there that is beyond the SQL that we typed into it. And that's okay, because these are the default settings behind the scene, because this is meant to be transportable between different database servers, and different database servers might be different, using different character sets and so on. That's not that important. I mean, you can even see there that the time zone is important. Oh, sorry, where's the time zone? There's the time zone. Okay, so like, because some records might have timestamps to them, and if you move them into a different time zone, it wants to retain those timestamps. A lot of details that we really go beyond the scope of this course. They're more at the level of the systems administrators and database administrators, rather than what we did in this course, which was design schemas and then implement them. Okay, and you can see the stuff that's in red. It begins with the double dashes, and so those are comments. And the stuff that's in blue are the default settings that we're just going to ignore. But here you can see it says structure for table address. Well, there you go. The first line says drop table if exists address. Okay, so just like there's a drop database if exists, there's a drop table if exists. Okay, so that clears out any table, and then there you go, it creates a table. You'll notice it looks an awful lot like what we typed, but there's a couple of things. There's a bunch of these little backticks, and those are special quotes. Okay, and you can see here, address ID is an int of maximum width 11. It's not null, and it auto increments, and it's also the primary key down there. Okay, notice that when I fed it my schema, I actually had the primary key up here. Okay, but when I pulled it back out, it actually changed the syntax, and it put the primary key at the bottom and using the new syntax. Okay, and of course there's the building number, the street, and so on. And then the entire table is we closed it and followed by a semicolon. But you take a look here, and there's all this extra stuff, and you go, what is all this extra stuff? Well, again, it's beyond the scope of this course, but since we're here, the engine, there are different internal formats to tables. InnoDB is probably the best. It's the most common one. It's an internal format which allows for very fast lookups, and it's very robust, and a very robust system for database table formats internally. The one that you might be interested in is this auto increment. Okay, and the auto increment basically says, okay, you know what? We're going to start at 7, and the reason we're going to start at 7 is because that's where we left off. So you remember, like, how when you auto increment, you're always going to auto increment, and you're going to pick up from where you left off. This is a way that you could say, where did you last pick up, or sorry, where did you last leave off, and it was at 7. Okay, and okay, so you know what, there's more, and I didn't teach you about locking tables because I didn't teach you about asset compliance, but there you could see that some data is being inserted into the right here. Some some information is being inserted into the address table, and it makes use of this very long syntax. Okay, so it's got the one tuple, comma, followed by the other tuple. It's actually a very, very long line, and it goes beyond the edge of the shell here. Okay, and then here's where it creates the customer table, and then inserts that into the customer table, and then it creates the manufacturer table and inserts that into the manufacturer table right there, and so on and so forth. Okay, we don't have to look at all the details, but basically, let me get out of this. Basically, let me just show you the history. This command here, that allows you to take an ASCII file there and feed it into the database. Okay, so this one, take the ASCII file invoice-data.sql and feed it to the database server. The MySQL dump does the exact opposite. It takes an already existing database in the database server and feeds it out to a file that you specify. Okay, And I think it's important, to have these. There's a lot more of these kinds of commands, but it's important to have at least a couple. How do you get the schema data into the database server? How do you get the schema data out of the database server? And so this completes that story. Okay, guys, that's the end of this lecture. All right. Next class, what you can expect is we'll actually look at some of our more interesting databases, the ones that more interesting tables. They're databases with the tables that we worked on with the when we did normalization. Okay, and we'll do some queries on those that involve joins, some complicated joins, and that'll be the end of the course as far as the material goes. Okay, I have yet to decide when you guys want to have a test, but I'll probably give you one more short assignment to play with the new syntax, and then we'll be ready for the test whenever you guys are ready for the test. All right,